Question 7, we've got a normal hypothesis test and the errors coming through here. We're doing a 1% test, and it's a one-tail test as well. So the first thing we've got here is that the size is equal to the significance level, which is 0.01. So there's the first mark. Now, X is normally distributed. We've got a mean of 15 and a standard deviation of 0.2, so a variance of 0.2 squared. We're going to do a sample of n of them. And so the mean of my samples are normally distributed, mean of 15, and a variance that's n times smaller. Now, if we standardize this, that means that z, which is equal to 15, to try and find out what our z go again. Let's find out, we want to find out what the critical value is. So the critical value is when the mean is less than the critical value we're trying to find out. Standardizing, that's what's just trying to do there, is we want C, take away the mean, divided by the standard deviation, which is the square root of that, 0.2 over root n. And we want the probability of it being in the critical region down there to be 0.01. So, bit of rearranging here. So if I just put 0.2 over root n there, and what do we get on a normal distribution here? So normal distribution, we want a less than, we want a standard deviation of 1 and a mean of 0. And so this, because the standard normal, and we want the probability here to be 0.01. So the value I'm looking for here is minus 2.326. 3263, let's put that there. So C is equal to 15 minus that times that, so that is 0.46526 over root n. That is my critical value at the lower end. Right, deep breath as we go on. So a type 2 error. A type 2 error is a type 2 error is we stay with this, isn't it? A type 2 error is we incorrectly accept H0. So this is the probability that the mean is bigger than this value here, given that actually the mean was 14.9. And then 0.2 squared over n again there. And we want that probability to be less than 5%, less than 0.05 is what we want. Okay. So standardizing, we're going to do the critical value, which is that thing there, I won't write it out, take away the mean, which is 14.9, divided by the standard deviation again, which is 0.2 over root n, and we want that to be less than, so inverse normal of 0.05 this time, menu, distributions, normal, we know this one, it's 1.64, isn't it? 0.05, 1.644, yeah. 1.6445, isn't it? So multiply that up there, gives us 0.32898 over root n. And putting that C in there, which is 15. So I've got 15 minus that, which is 0.1 minus 0.46526 over root n. So if we add that to both sides, then we get 0.1 is less than 0.79427 over root n. So divide by 0.1, I've got 7.94, and then square it. So I'm going to get n, I think, is going to be greater than at the end of that. I've got n is greater than 63.08, so I think n is 64. Tiny bit unsure about my less than's and more than's. What am I doing there? I'm dividing by something less than 1, aren't I? No, it's not there, is it? It's up here. That should have been a greater than there. That's it there. They're greater thans there. That's the bit. There we go there. And the last bit is just say, well, if you were doing a 5% test and a 1% test, then the type 2 error would decrease. The probability of a type 2 error would decrease if the size of the test went up.